that message, there was nothing being said. So it may also have been that there's nothing to hear. Can you send a message if you are good, and perhaps another message if send us another message if you still can't hear us. Well, that's unfortunate. Can other people hear me? Okay, well, I don't know what to say. Jeffrey, I guess you can't hear me saying this either. Yep. So I won't get too much into it before you rejoin. Anyway, I hope everyone's had a good week. We're on our second to last class, I believe, week 7 of 8. So we'll be, at the very least, wrapping up the sprocket machine, and maybe next week at the end, we'll have some time to look into something interesting, maybe something of your choice. But we can talk about that later. Let's see. So before we get started, does anyone have any questions about, I guess, any remaining questions
I have
about
a question.
The sprocket, or looking forward? Does anyone have any ideas about any of these parts that we talked about? So we identified that there were handles, the shaft going through the middle, the base or the stand here, and the links connecting the shaft to the handle. So if you have any ideas, if you have any thoughts about those, feel free to share them. Leo?
When I was watching the video recording, like when I was doing it accidentally turned red, and I don't know how to turn it back to gray.
Could you repeat the first part of what you said? I had the audio muted on my end as well, so I didn't catch the beginning of it.
It was like when I was watching the thing, like when I was looking at it, it turned red.
Are you talking about an on-shape?
Yeah, like on sketch 1, it turned red, and extrude 1, it turned like maroon color.
Okay. It's a very descriptive
and I don't know
description.
How to turn it 3D again.
Right. So what probably happens if something in the sketch turns red, that usually means something is over-constrained. So maybe you tried to add it.
How do I recover it to normal?
It'll vary a lot depending on what exactly you're doing at the moment, or at that moment. It'd be pretty hard for me to just say without looking at it.
It was like, right here.
So
this is the sketch 1.
All right, so again, even like looking at it, like all I can really say is that something got over-constrained. So maybe with the blue points that I see there, maybe you're trying to drag something and you created a relation accidentally that over-constrains it. I would say the best thing that you can do is like undo the last few things you're doing, or if you no longer have the ability to do that, just like delete and recreate the entities that you were working with. Otherwise, the only real solution is to go through every relation that exists in the sketch and try to figure out what exactly is not matching up. So I'd say for this class...
is it okay if you just don't do it, you just hang on to it?
Yeah, right now just
because
hold on.
On my extrude, it doesn't turn red.
Sure. If you have something that works, hold on to it. And if you don't, just hold on for a minute. And this class, our goal is to get through the remaining parts. So focus on just like working with the class and getting the other parts made. And then at the end, if we have time to assemble it, I can either, we can figure something out. I can either send you my version of the sprocket, or we can work through, or you can try to redo it yourself in the meantime. So anyway, welcome back, Jeffrey. I'm glad you've returned to us. And we'll begin, let's see. Unless anyone has any outstanding preferences, we'll just start from the center and move out. So we made our sprocket, and now we'll try making the shaft in the middle, basically the rod that goes through the sprocket and keeps it supported and connects it to the other components like the stand and the handles. So I guess, yeah, before we get started, question I always like to ask, what shape do you see? This little rod, this shaft that goes through the middle, basically what shape is that? How would you go about creating it using the tools we have? Someone says line. A cylinder, right. And we know how to make a cylinder, hopefully. And actually, hopefully we know more than one way to make a cylinder. So let's get into it. Open up the document that you made last week, which you hopefully named something descriptive like your sprocket project or something of that nature. Whatever document that you made your sprocket in, make sure you're in that one. So don't go back and like create a new one, just stay in here. And at the bottom of the window, you'll see their tabs. So the first one, you can rename into something descriptive using the rename feature. And then you want to make a new part studio using the plus sign here, which allows you to create a part studio. And when you do that, it'll appear right next to it as something like Part Studio 1. And again, we can rename it just to keep our workspace organized so we know what we're looking at. We're going to call this one shaft. And in the chat, I see again, someone says extrude a circle. And so I do agree that that is one of the ways that you can do this. And that is probably the way that we will do this. So at this point, I'm sure you're all experts. You know how to create a sketch. Doesn't matter what plane, really. I pick the front and create a circle.
Did you just delete the whole thing?
Are you
what
talking
have
about?
we been doing? I just joined. I was at a play date.
Sure. No worries. Leo, about your question, what do you mean, did you delete everything?
Did I delete everything?
Like, because it's the same. Did you do the same? Is this a new one or is this different?
I'm in a different part studio in the same documents. My sprocket is here and this new thing is here.
How did you go to shaft?
So I hit the plus sign, and from there I can create a new part studio, which will create a new tab at the bottom. And I'm working in this part studio in the same document.
I can't see. Sorry. Oh, here.
Part studio.
I can't see a shaft. Okay.
All right, so shaft is the name that I gave it using the rename tool.
Oh, it's actually part 2 studio 2, right?
Yes, it'll be part studio and a number, depending on which number it is of.
Oh, we've just started making a circle.
Studio.
Oh, I didn't miss much.
Yes, that is correct. All right, hopefully you can catch up to
how big the circle is.
The circle, and that's a great question. How big is the circle? And to answer that, we need to take a look at what the shaft is going to be interfacing with. And so we see the shaft here, which is basically a cylinder. It goes into this part of the link. It goes through the base and it goes through the sprocket. And so just based on that, we know that it should be the same diameter as
we're working
the
on
center
that
hole in the sprocket.
We're working on we have to get the exact size of the circle.
Right. So once we assemble things, these parts are going to be interfacing with each other. So we want them to match each other for their dimensions. so that they'll fit properly.
Sheesh. Oh no, wait, never mind. I'll do it now.
So we need to go back and we need to figure out how big this circle was that we made in our sprocket.
Mine is 2.
So an easy way to do that is just go back and edit that sketch. Apparently it was not that one. Let's see, it's probably this one for me. But if you go back and edit the sketch, you can easily see the dimension where you created that feature. So
wait, how did you get all of them black? Like when all you did was like do a few of them. I had to do all of them to get them all black.
I'm not quite sure what things you're talking about.
Like,
This
can I share my screen?
Is a circular pattern. So once you dimension them, they all turn black. Or once you constrain that center of rotation, they all become black.
Oh, okay.
Feel free to share if you still have an issue.
Because mine looks really weird. Mine just looks like this.
Right, so if you have to do that, that probably means you didn't directly put a relation on the center of rotation of your circular pattern. Rather, you explicitly dimensioned all of them together so that they would be like fully constrained. So that also works.
It's just harder.
Right. So in a previous class, I showed you like how you can like drag out one of the points and that reveals the center of rotation, and you can just add a relation to that. So like no real worries there. Another thing you can do is if you just click on a feature, like here, I selected the circle here, and you can see it's highlighted. And in the bottom right corner, you can see it tells me the diameter of that is 0.375, which is correct as we just saw. And one other thing, if you just click on this tape measure at the bottom here, that actually brings up a new tool, which is called the measure tool. And this can do a lot of things. It's kind of like the dimension tool in that it is smart. It kind of tries to figure out what you're trying to measure. But if you just click on something like a circle, it'll tell you that the diameter of that circle is 0.375. So now we know. I go back to my shaft and I go back to the sketch with a circle in it, and I'll simply dimension it to have that same dimension, which in my case is 375, not 75. And in your case, it's whatever you just found out that it was by measuring it or looking at your sketch.
That looks so small from like when you are in front.
Yeah. Some CAD programs, when you create your first dimension, it'll just like keep it.
But I don't know if my
view.
thing is 2 inches or 2. I don't know if it's 2 inches or 2 centimeters.
It will be in whatever your default dimension is for your, like whatever the default dimension is. Just, if everything has been centimeters up to now, it's probably centimeters. But the way you can find out, like,
okay, it's centimeters. I created another circle.
Yeah, if you want
No,
to.
the one we made was 3 inches.
If you want to check without ambiguity, you can always use the measure tool, which will specify a unit. So
mine's
if I
inches.
click here,
So
I know that it's inches. If I change it to centimeters, I know that mine was actually 0.953 centimeters in diameter. So that's a way to tell. In any case, we have our circle here.
My sprocket is the center circle is 2 centimeters.
Is this one supposed to like the circle 0.375?
It'll depend on whatever you made yours to be. So just go off whatever
Mine was the same thing you did last class.
All right, so what I had was 3/8 or 3.375.
We're supposed to make one that's 1 inch.
Right, so now we're going to extrude the circle as somebody suggested to create this shaft here. So again, now we kind of have to guess at what our dimension is going to be. So it's admittedly pretty hard just looking at a model on your computer screen to kind of gauge how big it would be in real life. Of course, you know the numbers in some sense. Like I can tell you right away that the thickness of the sprocket is 1/4 inch. And maybe if you have worked with a lot of measures in your life, you have a good sense of how big 1/4 inch is. but maybe you don't. So good thing to do is just like think about like aspect ratio, or like proportionally how big things are to kind of look right. And the great thing is that even if we're wrong, we can always go back and change them, because it's kind of a creative project where we have a lot of freedom over the dimensions. The only constraint that we're really working with is that everything needs to fit together, and otherwise we're free to do whatever we want. So let's say looking at this, I say I want it to be like 5 inches long. And in terms of my aspect ratio, I think that looks pretty reasonable for something like this. Maybe it's a bit long, but we'll find out when it comes to it. Do you have a question, Henry?
So basically my thing is my entire, is it width or length?
Depends, I guess.
Like basically my entire depth or like thickness is 2.5 centimeters.
Okay.
And so basically if I make so would it be good that I make the extrude, the extrude for the shaft like 7.5 so that it fills in the center area, but also gives the side. Oh no, wait, that's too small. Never mind.
Yeah, just think about what it's going to be doing, right? It needs to extend far enough out of both sides of the sprocket so that it can both rest on the base and have something like a handle at the end of it.
12.5 centimeters, because I can have 0.5 for each side.
And so with that, basically we're done. That was the whole part. So congratulations, we can begin the next one. So we're going to create another part studio, just like we created the one we just have, using the plus sign, and we can start the next thing. And how about we do the base? So this little stand here.
Wait, how do you create another one again?
Same idea, plus sign at the bottom, and
Whoops.
you have the options to create a few different things. If you want is part studio, you can right click the tab, rename, and we'll call this base.
Can I rename the ensemble one just ensemble?
Sure, you can you call it whatever you want, right? All right, so again, we're looking at the base, and I'll ask, what kind of shapes do you see?
What's the base?
This thing here.
Like the triangle-y thingy?
Sure, yeah, the thing that holds up the shaft.
Well, I see triangles, but like at the top they're rounded and I don't know how to round them.
Sure, yeah, I'd agree. It's like,
can you use the fillet tool to round it?
you definitely can. So let's see in the chat, square on the bottom, line, circle. Yeah, all good answers. The main idea here is that from the side view, kind of if you're looking into the sprocket so that you'd see like the face of the sprocket. It's kind of like flat at the bottom, and then it tapers as it goes up, and at the top it's round, and that's where the shaft goes in. So I guess we'll start out by sketching that, because that's the easiest thing to do, right? I guess before we get started, maybe I'll pose this question to you all, like, how would you create this geometry? How would you make this shape? So from one side, the answer is that you've given. Yes?
Like maybe I would put like, I don't know, like maybe you could put like 2 triangles and then you could try to put a square on the base, but that probably wouldn't work. Maybe you can use like the what is it called again? The circular, what is it called? I don't know, I forgot what it's called. Oh, the circular pattern thing to duplicate it on the other side. I don't know.
So those are all good ideas. And the thing you said about like you can make two of them and have like a square in the middle, that would also work. The idea would be like you'd somehow offset one of them so that they're a distance away from the first one, and then you create another thing at the bottom. So yeah, that would work. That is an approach that you could use if you were doing this like on your own. And yeah. Anyway, we'll start off with our sketch, and we'll just focus on making the side view of this stand. So again, the flat on the bottom, and it tapers as it goes up, and then it's round at the top. So I'll start off with the line tool, since that makes the most sense to me. And I think in the chat, someone suggested like square on the bottom, line, circle. So I like that idea. I know that on the top, I need like a circle, and this is going to be the hole where the shaft goes through. And then kind of like we did for the gasket, we were trying to make that lemon shape. To get that outer rounded part, I'll create another circle. So I have something like this, and I just need to connect things together. So I'll use my relations here. I want this line to be tangent to the circle, so I'll apply that relation. I also want this line to touch the circle. That's my coincident relation. Same thing on the right. I'll make them coincident and tangent. So now this shape is more or less what I wanted. Kind of drag them around, play with it to see, what I like.
Wait, what do I apply with the tangent thing again?
For tangent, you want to make these lines tangent to the circle, just so you get this nice transition between the line and the circle. Otherwise, you might get a sharp cusp where they meet, or they might intersect each other, neither of which we really want. And one more thing that I'll do is make these two lines equal, because I want this space to be symmetric. So now when I drag things around, we'll kind of maintain this relation.
When can you like change the size to like be fit? Because I don't really have that much space.
You can zoom in and out to scroll if you're talking about like your view.
I meant like I don't have that much like. Never mind. I think I know how to do it.
So now that we have this basic shape, I am more or less satisfied with the relations now, because no matter how I drag the various points around, it still keeps the shape that I want, right? Being like the symmetric thing, it's flat on the bottom and it's rounded at the top. So what I'm going to start applying now are my dimensions. And again, we have the same question: how big do I make this thing? And right now, the only real constraint that I know about is that it needs to be able to hold the sprocket inside of it. That means it needs to be tall enough so that the sprocket doesn't go through the bottom of the base. And it also needs to have a hole going through here that's the right size for the shaft. So we'll start with that one first. That one's easy because we just measured it. I know in my case, for example, that the diameter of the hole here is 3/8 of an inch. Do you have a question, Henry?
I'm still on the circle part. How do you connect the circle to the line again?
For that, you can just use a coincident relation,
or
you can drag the point onto the circle, and usually that'll like snap it and create a relation.
It said a coincident constraint cannot be applied to two curves of different types.
So you're probably trying to make the line and the circle coincident. What you want is to make the endpoint of the line coincident to the circle.
What do you mean?
So rather than selecting a line, which I'm guessing that you're doing, select the endpoint of the line and the circle, and then apply the relation.
But what? It's so big. It still has like no constraint.
So the only like relations that I have here so far are this one is horizontal, and I kind of got that one like implicitly by creating this line along the x-axis. I have that these two are equal. I have that this is tangent to this, and likewise, this one is tangent to this. I have that this point is coincident to this circle. This point is coincident to this circle. And these two circles are concentric, which again was implied because I created the second circle with the same center point. And if you have that much, then it should follow like this basic kind of relationship.
If you do what again?
Yeah, basically the only relations that I like really created explicitly are these two lines being equal, each of these lines being tangent to the circle, and each of the lines being coincident to the circle. And you'll notice mine is not fully defined either, because I need to apply my dimensions still. And the first dimension I get from knowing about the shaft and the sprocket, which I just made, and those have a diameter of 0.375. So pretty instantly, I know what that's supposed to be. And then I can start applying them, which is kind of to my taste. Again, it's kind of a artistic project. We're not really designing a machine component. We're just making this for the sake of our practice and improvement. And this can kind of help you get a sense of how to like dimension things, right? So again, when we all go to the assembly together and we start putting these together, you'll see how good or bad your guesswork was for how big things should be, and you can always go back and change them later. So the other thing I mentioned that was important is that the base needs to be tall enough for the entire sprocket to fit inside. So the height from the center of where the shaft goes to the bottom of the base needs to be at least the radius of the sprocket. So I can quickly go back to my sprocket. I'll go to my first sketch. I'll just quickly remind myself what I made this radius. So my diameter for the sprocket was 3 inches. And knowing that, I know that the whole height of this thing needs to be greater than 1.5 inches, but technically 1.5 inches is actually, that's actually too short. So maybe 2 inches or more would be enough. And you'll notice that there's no like explicit feature here that tells you how tall my shape is, but there's a couple ways that I can do this. The first one would be just use the smart dimension tool. The smart dimension, being as smart as it is, can create a vertical dimension for you. If you select a point and a line, for example, that will create this vertical dimension. And I can call that, for example, maybe I'll say 2.5 inches, make it extra tall. So I can create a dimension like that, a distance between a point and a line. Another thing I can do is use my construction geometry. So you can recall that whenever you are trying to create a sketch entity that's not going to be a part of your final geometry, what you can always do is create construction geometry. I can create a line, for example, from this point to the bottom here. And if I turn that into a construction geometry, then I know that it's just for me. It's just for the person looking at the sketch, so that they have some helpful things in the sketch, not so that I can use it to create something in my 3D part. So either way works. If you create this construction line, then you can just dimension the construction line and you can call that 2.5 inches. Yeah, but either way works. It's up to you.
Question.
Yes.
Where do you find the diameter again? Like on the sprocket in teeth?
All right, so for the sprocket, probably the diameter is in your very first sketch where you created this circle. So for me,
is it like the diameter of the circle?
Technically it's the outer diameter, so the distance from the end of one tooth to the end of the opposite tooth, but I added a little extra distance.
Mine is 7.62 inches, so.
Right, so you need at least half of your sprocket diameter plus a bit of extra just because, you know, you got the thickness of the base at the bottom.
4.
And so on. And again, if you are a fan of the measure tool, you can always just measure point to point. So something from there to there is probably pretty close to the diameter of my sprocket. You can see that actually it's 3.4 inches if you include the teeth as well.
Wait, should I make like the height? Can I make like the lines on the side also 4? Because that looks more like, wait, I should make this 5. How long do I make like the lines on the side?
If you're talking about the base again, you'll find that if you use the relations and dimensions like I have, you don't actually need to dimension like these lines.
How is yours like? I need to make my center one 2 centimeters because the area the circle of the center circle of my sprocket is 2 inches. But it looks so big.
The only thing I can say about that is make sure the units are all right, but we'll find out when we get to the assembly in any case. So
yeah, mine looks good.
And one last thing that I'll point out here, this thing is like kind of optional, I guess, but what I emphasized in the past is how you should always make sure your solid lines represent part boundaries. So here I'm kind of breaking that rule. I have this semicircular arc here that is a solid line, even though this isn't part of my boundary. So if you're a real stickler, if you want to follow that rule, you can simply turn this circle into a construction circle and then use your arc tool. So I'll use my center point arc and just create an arc like so. This is pretty optional. It just makes your life like the tiniest bit easier in the next step, but not really. And it's a lot easier for people to understand because looking at this, now there's only one closed sketch region in my sketch. So
how do you do that?
Yeah, optional step there. It's the exact same thing that we did for the gasket when we were trying to make these inside arcs construction arcs. You just use your construction tool to toggle things between being construction and not construction.
Oh.
And then the arc tool, hopefully. Center point arc, it's center, start, and end points. So you click on the center, click on the start point, click on the end point. And then I'll accept my sketch.
That looks way better.
And now I can extrude it. Same old tool that we've always used. I click on my region, and if you did the optional step, then one click and you're done. If you didn't do the optional step, you probably have to click twice, once for this guy and once for this guy. Or if you didn't do the optional step, you can also just click on sketch one, and it'll probably select everything that it can. So just like for the sprocket. And then for the depth.
Why does it look so clean?
For the depth, we need to think again about what it needs to be. And looking at this, the only real constraint for how deep, how thick the extrusion needs to be is that it needs to be thicker than the sprocket, plus a little bit extra for the thickness of the stand itself.
Can I see the thing again because I'm slow?
What do you need to see?
Yeah, I need to see the base. Like the other way.
I don't know if
Okay.
I don't know if mine is 1 centimeter thick or 2.5 centimeters thick. Because the one that's 1 centimeter thick looks exactly the same as the one that's 2 centimeters thick. Wait, the depth is the thickness, right?
For the extrusion, the depth is how far along the direction normal to your sketch regions, like how much to,
yeah,
like it's the length of this line is the depth of your extrusion.
1 centimeter is exactly the same.
Jeffrey, do you have a question?
Yeah, so when I extrude only the circle extrudes.
That's probably an issue with the sketch regions you're selecting. So
okay.
Yeah, you can always X out the, like everything basically, and then select them again. And then to select them, you just click on the regions.
Mm-hmm.
All right, now
0.5 centimeters more enough.
I guess you will find out when we get to the assembly stuff.
Like when you do like the thing that the construction thing that has the one of the curve like right there, right here, right here. How do you make it like that? Because when I do it, it only just does the whole entire thing.
Right, so it does the whole thing, and then what you do is you fill it in again using an arc.
Oh. Okay.
Right, so yeah, if you have any doubts about the thickness of this, just make sure it's like more than, say, twice the thickness of your sprocket. Maybe a bit more than that, maybe like 3 or 4 times.
But like when I have this construction, it only has a construction. It doesn't have like arrows next to it.
Not sure what you mean by arrows.
Like like when go back to sketch 1, like right here. Wait. Then how did you do the line to make it fill in? Oh, that.
What line are you talking about?
Like what do you use this line to fill it in?
No, I used the arc tool.
Oh, okay.
I have a question. Can you show me how the thing is supposed to look?
What thing?
How the entire thing is supposed to look on the Google Slides.
It really doesn't need to look like this. It's just a starting point for our ideas. In any case, we're going to move on to the next step, which is creating this like clearance in the middle. This
when the arc like it makes it makes a new one.
If you can't get that part to work, just don't worry about it. It's really optional, and the only real point of it is to make it clearer for other people who are looking at your sketch. But
I don't know what's
not really a top concern here. Henry?
I don't know if I should do 8 centimeters or 6 centimeters.
I would guess that it probably won't end up mattering. Don't worry.
Because my sprocket thickness is either 2.5 or 1, and my length of my shaft is 12.5.
Like I said, like it really won't matter. You'll get to the assembly step and you'll figure out whether or not you need to change it.
Oh, okay.
What we'll do now is go kind of to the right plane, or in your case, whatever plane is perpendicular to the one we were just in, so that we are looking now at the side of our base. And we're going to use our Extrude Remove tool to cut away a rectangular region from the side, so that what we're left with looks like what we have in here. So what we're going to do, we're going to create a rectangle, and we need to somehow relate this rectangle to the thing that already exists in here, but which isn't part of our sketch.
You created a rectangle? Oh no, wait, you created another sketch.
What you'll find is that you can actually refer to things that aren't actually part of your sketch, but which are visible in your sketch, and kind of use them for your dimensions or relations. So this entire gray, like 3D body, none of this is in my sketch. I just created the new sketch, and the only thing inside of my sketch is this rectangle that I just drew. But you can see that I can still like click on these points. So we're going to take advantage of that. We're going to use that to create our dimensions. And these dimensions will kind of be to say how far this rectangle that I drew should be from the edges of the part. So like before, the way you can dimension a distance between two lines is to click the dimension tool and then click the two lines in order. And then I'll just give it a value, maybe 0.2. Again, dimension tool, line, another line, put in a number, dimension tool, line, put in a number, and finally, this one really doesn't matter, but I'll just make it extend. Say past this one by enough so that it comes out beyond the top. So here's my rectangle. All I did was create a rectangle using my rectangle tool, and then I applied 4 dimensions to it with respect to this 3D body, which, like I said, it isn't in my sketch, but Onshape allows me to use it as a reference in my sketch. So the idea is that you have a rectangle which kind of forms like a uniform thickness perimeter inside of the gray body, like so. And what I can do from here is, if I accept the sketch, I can use the Extrude Remove tool, which we talked about last time. You create an extrusion, and instead of new or add, you do a remove. I select that rectangle that I drew. You can see by this red shape that it's trying to extrude remove in the other direction. So that's not the direction that I want. And to change that, I can click on this black arrow to reverse the direction. And then instead of blind, remember blind means it just blindly goes the distance that you tell it. It doesn't think about, it doesn't look where it's going. It just blindly goes 1 inch or whatever. Instead of blind, I'll just say through all. And through all means that it just goes through everything. And that's what I want here. And once I accept that, that's my base finished, right? It's basically what I wanted. Henry?
So basically, how do I make the top line of my sketch 2 square, like, how do I make it black?
That one honestly is the one that matters the least. The only thing that's important is that it extends past the extent of your body here. And I just arbitrarily gave it a dimension so that it would extend past the top. You can choose like any pair of lines and just make sure that it's long enough. Like that would work too.
Yeah, I got it.
All right, so that's our base finished. And now we just have two more parts left, the handle and the link. Since we are pretty rapidly nearing the end of our time, I'm going to start with the handle, just in case you don't get to the link. And the handle is pretty interesting here. So take a good look. And instead of asking what shapes you'll see, I'll cut straight to it and ask you what you would use to create this kind of shape. The handle here, the part you grab onto with your hand. What tools have we learned that make it a lot easier to create that kind of geometry? To make it a bit easier of what I'm trying to convey here, would you use an extrusion or a revolve to create this handle shape?
What do you use, a what or a what?
Would you extrude or revolve to get this handle shape?
Revolve.
Cool. That is
Incorrect.
an assessment that I would agree with.
Oh no, wait, never mind.
And so now the bonus question is, how do you, I guess I was going to ask what shape would you create to revolve into this shape, but it's not really a good way to put that into words. So I'll just go right in. I created a new part studio and I named it handle, same thing you saw me do for the shaft and the base. And I create a sketch in any of the planes. Doesn't really matter. So once I'm in my sketch, you recall from what we did with the Revolve tool before, we've made things like a donut or a sphere. And the way it works is that the shape that you draw in your sketch, that's going to be swept around an axis of revolution, or an axis of rotation. And once that happens, that axis becomes your axis of symmetry, right? About that axis, you basically have a rotationally symmetric part, which has a cross section that looks like whatever sketch you drew. So get a good image of this handle in your mind. Doesn't have to be perfect, but we're going to try to create that cross section, specifically half of that cross section, and then we'll revolve it and we'll see what we get. So I'll make my handle just lying horizontally. You can make it vertical, doesn't really matter. But the first thing I'll draw is the line, which will become our axis of symmetry. This is a line that we're going to revolve our handle about. And from here, I kind of have a bit of artistic freedom in that the handle isn't some like geometry, like it's not like a sprocket, which has to be a circle. This handle can really be anything that you want it to be. And so you have the freedom here to do basically anything that you like. What I'm going to do is I'm going to use the arc tool. I'll use the center arc tool. And I'll just create a round part, start at the end of the handle. And from here, like if you want to be creative, feel free to make whatever shape you want. For the sake of simplicity, let's see, what would be a simple way to do this?
When I try to do the arc, 3-point arc, it just does like a bunch of construction lines with circle.
Can I make an entire circle?
I'm not sure what you mean by the whole 3-point arc thing, but
Like
use whatever
what?
arc tool makes the most sense to you. That is what I'll say.
Like when I do it, it goes on the, it curves on the right side.
I'm not really sure what to make of that, but what I'll say is here. What I did is I used the center point arc. I clicked just somewhere on my line because I know I want the center of the circle to be on this line so that when I revolve it, it'll be smooth at the tip. I click one of the points, I click anywhere, and that's kind of my arc right there. And then I create a line.
How do I know how long to make it?
In terms of dimensions, that's again, we're gonna have to use some guesswork. Note also that I use the tangent relation there to make this arc tangent to this line. And the reason for that is just to make it smooth as it transitions from the arc to the line. And overall, this is a pretty simple shape. If you want it to look more like the one here, you're gonna need like some more arcs and some more, basically some more arcs to make it have this kind of shape. So if you want to, feel free to try that. But for the sake of having something really simple to demonstrate, I'm just making this here. Now, to apply the dimensions, again, it's a lot of guesswork and a lot of creativity, I guess, since there's no real constraint on what size this thing should be. I'm just going to put some numbers here that I think are reasonable. And at the end of the day, when we get to the assembly, we will find out one way or another whether my guesses were reasonable. So we can do the same. Don't worry too much because it's really not a lot of trouble to go back and change it once we have the whole assembly and we know what we actually needed. Right, if that happens, if you ever make a dimension and it blows up your sketch like that, my go-to is always to undo what I just did. And what happened there is kind of try to bring the end of this arc back around to find the other solution.
Can I share my screen for a second?
Since we're so close to the end, I'm going to ask you to hold on for a bit, see if you can resolve it.
If I create the thing again on the bottom, will it make the circular shape on the end? Like I created the same arc thing twice, with the same shape again on the bottom.
So you don't need to make anything on the bottom. Remember, the revolve will go around 360 degrees. So like you only need to create half of your, whenever your axis of revolution is like going through your part, you only need to create half of it. If that makes sense.
I really don't know how long to make it.
Like when I do the dimension for 2.5, it just goes much further than like only 2.5 because it goes like much, the line goes much more longer.
I'm not really sure what to make of that.
And I don't know how to erase mine.
You can always undo using your like standard keyboard shortcuts. So Control-Z or hit the undo arrow here. But the basic construction that you want is something like this. And at the end of the day, if like all this is too much for you, don't be afraid to just make a cylinder for your handle as well, which you know how to do. Same as a rod, but you can also revolve a rectangle and that'll turn into a cylinder, as you might imagine. In the interest of time, I'm going to move on here. And if you need to catch up, you can always go through the recording. What I'll do is create a Revolve feature, and that'll, as we've seen before, ask you for a region and also for an axis. The axis here is this line along the x-axis that I created. And having selected those two things, you can see that it revolves into a shape something like this.
How do I make it all black? Again, I forgot.
Yeah. In terms of like fully defining a sketch, the hint that I gave before and like what I generally do myself when I'm struggling to fully define my sketch is to find all the blue points and drag them around and see how they can move, and just apply relations or constraints or relations or dimensions until like that degree of freedom is eliminated.
Like when you do the 2.5 is this blows up. I don't know how to fix it. Like it.
I would suggest on your own time after the class to try recreating the sketch from the beginning, and you should be able to do it.
Okay.
All right, so the last part that we have here is going to be this link. And so that's the part here that connects the shaft to the handle. Again, we're going to create a part studio, and I'll call it link. And so we're not going to be able to finish it this class, but I'll say that I do want you to make a attempt at this before the next class so that you have something for next week when we'll try to start assembling and actually finish assembling, since it'll be our last class. The idea here, think about what shapes you see. So you need to have something circular here with a hole in it that can fit over the shaft. So you know what dimension this end of the link needs to be. At this end, you want it to match the handle. So whatever diameter your handle has at the back end of it, whatever this diameter is, this end of the link needs to match that diameter. And between them, you have kind of a tapered rod. So keep that in mind. Think about what shapes you'd use. Think about what features you'd use. In this case, you probably extrude a shape that looks like this, kind of like dog bell or dumbbell shape. And based on what you know up to now, what you've done, you should fully be able to create that part. So do you have a question, Henry?
Oh wait, never mind. I figured out how to do the revolve.
All right.
It looks like a microphone.
So that's as far as we're going to get this week, given that we're out of time. But next week, we will get through the assembly. And for those of you who had trouble with the parts, at the start of next class, I can either make like my version of the parts available for you to download so you can do the assembly, or we can like have some time at the beginning to answer questions. And yeah, I make sure that we get through assembling this thing so you can see like it move around. And otherwise, if you have any last questions, I can stick around for a minute or two to answer those. And if not, have a good week, rest of your weekend, and I'll see you again for the last time next Saturday.